Okay, here without actually performing the long division, I have to tell whether each of these fractions, if I write it in the decimal expansion, then whether they will be terminating or non-terminating repeating form. So whether they will terminate or not, or they will be repeating in the particular sequence. So how can I tell that? I know that if I divide a number by 2, then it will surely terminate, and if I divide a number by 5, then it will surely terminate. But if I divide by a number by 3 or a 7 or any other prime number other than 2 and 5, then it will not terminate. It will be non-terminating repeating form. Therefore, for a fraction to have a terminating decimal expansion, its denominator should be of the form 2 to the power p into 5 to the power q. That is, it should have only the prime factors as 2 and 5. If it has any other prime factor, then it will be a non-terminating repeating decimal expansion. Okay. So if you look at the first part, what is the denominator? Denominator is 3125. Its prime factorization will be, this is divisible by 5, right? So 3125, if I divide by 5, I will get 6, 2, 5, right? Which I divide again by 5, I'll get 125. Which if I again divide by 5, I will get 25. Which I again divide by 5, I'll get 5. Therefore, I can see that all its prime factors are 5's. 3125 is equal to the 5 to the power 5. And we can see that this is of this form. So 3125, the denominator is of the order 2 power p into 5 power q. Therefore, this has a terminating decimal expansion. Okay, I would like to denote terminating as t and non-terminating repeating as non-terminating repeating NTR. Okay, or even just R. Okay, so this has a terminating decimal expansion. Okay, and if I look at the second part, the second part has a denominator 8, which is equal to 2 into 4, or 2 into 2 into 2, which is 2 cube. So this is also of this form, correct? So this will also have a terminating decimal expansion. If I look at the third part is 64 by 455. As you can see, I am not looking at the numerator. Numerator can be any number, but as long as the numerator is an integer, I just have to focus only on the denominator. If the denominator is of the form 2 power p into 5 power q, then I can tell that it has a terminating decimal expansion, irrespective of what are the factors of numerator. Okay, so for the third one, 455. 455 is divisible by 5. So if I divide it by 5, I'll get 91, right? 91, if I try to factorize it, it is divisible by 7. So 7 into 13, correct? 455 is equal to 5 into 7 into 13. Here it has the prime factors 7 and 13. Therefore, this is not of this form, 2 power p into 5 power q. Therefore, this fraction cannot have a terminating decimal expansion. It will have a non-terminating repeating decimal expansion. Okay, and the fourth part is 1600. I know 16 is equal to 2 to the power 4. So this is equal to 2 to the power 4 into 100, which is equal to 2 to the power 4 into 100. I can write as 10 square, right? What is 10? 2 into 5. So 2 to the power 4 into 2 square into 5 square, which is 2 to the power 6 into 5 square. As we can see, this is of the form 2 power p into 5 power q. So this decimal has a terminating decimal expansion. And the fifth one is 343. It is the denominator. So 343 is not divisible by 2 and it is not divisible by 5. So whatever beats prime factors, they are other than 2 and 5. Therefore, its 343 cannot be written in the form 2 power p into 5 power q. Therefore, I can directly say that this has a non-terminating repeating decimal expansion. I need not have to even find the prime factors of 343. I can directly tell it because it doesn't have the factors 2 and 5. Therefore, it has other factors. Sixth one, denominator is 2 cube into 5 square. It is of this form. So, it has a terminating decimal expansion. Here, 2 square into 5 power 7 into 7 power 5. We have a factor of 7, which means that this is not of this form. Therefore, it has a repeating decimal expansion. 15 I can write as 3 into 5, correct? This again has the prime factor 3. So this cannot be written in this form. So this is also a repeating decimal fraction. The next one is the ninth one, which has the denominator 50. 50 is equal to 5 into 10, which is 5 into 5 into 2, which is 5 square into 2. This is of this form. Therefore, this has a terminating decimal expansion. Here it is 77 by 210. Here there is a factor of 7 in the denominator, but there is also a factor of 7 in the numerator. So let me first try to simplify it, because if I see that there is a 7 here and try to conclude that it is repeating, it may be wrong because there is also 7 in the numerator. So I'll try to bring it to the lowest terms. 77 by 210 can be written as 7 into 11 by 7 into 30, right? So if I cancel 7, I'll get it as 11 by 30. So if I look at the denominator is 30, which is 3 into 10 or 3 into 2 into 5. Here the denominator has a factor 3, which is not there in the numerator. That means that this cannot be removed. So we cannot bring the denominator to this form. Therefore, this has a non-terminating repeating decimal expansion.